secondary value. But now, to get all the values, I have to do what? I have to add n times the period, which is 360 degrees to each of these. Okay. So I have a handout, and I want you to try the first 4 problems. Let's go ahead and do the first 5. Okay. Repeat up for everyone. When you're doing that, head up here.
Oh, we need one
Everyone
more.
got one?
We need one more.
2 more over here.
No.
Just one.
You're just one.
Oh,
Are you him too? Oh,
No,
I
no, for him,
I
yeah.
see. Advocates. All right, anyone need one? If you're really sloppy, go ahead and take 2. You have some advocates. Okay. So, there's some links people here. Ava is not here. Caitlin, Chetna, Jessica, I saw Jessica. Sola. Anybody else show up late? didn't say use good judgment. And if you don't like that, three decimals is fine. Right? Oh, Caitlin, you're here. Not absent. While you're working on that, I just thought it might be useful to, if you haven't seen this before, what happens on your calculator if you try and put in a function but outside of its domain, right? So the inverse sine of 2 doesn't sound very good, does it? Okay, look at that. Error, domain. Quit or go to. You know what quit does? I have no idea what go to does.
To fix it.
You get to fix it?
Yeah, show you where's the error.
Point to. There we go. Now it's happy. It's good to know that in the heat of a quiz when your calculator is giving you something like that. Right? You want to. No, it's a domain problem. Oh, and lest it not be clear, like on a quiz, for problem 1, I would tell you I want the exact value. But if you see something like square root of 3 over 2, aha, that looks like something I can get an exact value. You should. Same with minus 1, 1. Obviously not for 0.777, right?
I'm getting error domain on the
Okay,
last.
did you check your mode? Oh, probably the mode, no, the mode wouldn't matter, would it? Okay, what are you plugging, tell me what you're typing in.
The number 7.
Number 7.
Yeah, I don't know how to do that either.
Yeah, I didn't say do 7, I said do the first 4.
Ah,
Sorry.
I did all of them.
I did all of them.
Ah, but
Except
did you do them right?
You didn't
Yeah,
say
I don't know, but
first one.
Did
You
you
didn't say
find
the
the
four.
inverse secant function?
yeah, it's,
Did you find the inverse secant function on the calculator?
yes.
For the 7th one, no. For the 7th one, keep saying error.
How about the inverse cotangent? Did you find that? Those don't seem, they may be buried somewhere.
No, I got it for the code.
There's this
It can the
thing down here called the catalog, right?
sinus x can be 2.5.
Let's see. Cosine,
Because
cosine
it's from
inverse.
-1 to 1.
Hyperbolic cosine? Hyperbolic cosine inverse? Oh, okay. So we're interested in like the cosecant inverse. Oh, it doesn't seem to have that. Well, we're going to talk about that in a minute, but that's ahead of the game. Okay, so everybody at least through 1 and 2? All right, let's take a look at this. So here we want to find inverse sine of negative square root of 3 over 2. So I guess the first question I have is where do you find an angle whose sine is negative?
The third and fourth quadrant.
Third and fourth quadrant, very good. And in particular, we find the principal value in the fourth quadrant because, let's take a look at our little diagram here, right? The range of the inverse sine is minus pi over 2 to pi over 2, right? So that means we want to look from, minus pi over 2 up to pi over 2. But it's going to be negative over here, right? So the sine value, this value here, is going to be, for this triangle, is the square root of 3 over 2. Hypotenuse is 1. And again, you want to be able to recognize these things in your sleep. What's the third side, the leg? It's 1/2, yes. Yes. And this, of course, is a 30, 60, 90 triangle again. So we know the angle here is 60, or if you like, pi over 3, but because it's down here, it's, I should have thought this through, minus pi over 3. But as before, if we draw a horizontal line here, we're going to find another value. Right. This one, this angle here is 60, so this angle here is 120 or minus 120, right, or minus 4 pi over 3. That's not right.
Yeah. Because 3 pi over 3 would be pi.
No, that's not right. They're supposed to add up to pi. It's got to be 5 pi over 3. They're supplements. Okay, so you also, you can convert those to the positive values if you wish, but we're going to have to add 2 pi and each of them to get all the values.
Is it okay if we had any degrees like 240
It's
degrees?
perfectly okay if you have degrees, unless I ask.
Okay.
Should it be minus 2 pi n, since you're going in a negative direction, and you're making a revolution?
It could be, but it doesn't matter. We're interested in all the values, the positive and the negative. And n refers to an integer, not just the positive integers. So yes, if you said minus or plus negative 2 pi, and you get positive values by putting in negative n's. I don't think I said that very well.
I see what you're saying. I think it's a grammatical thing, but because
There's nothing
you can't
wrong
have
with
a,
it.
you can't really have a negative revolution.
Well,
It's
we're
just
not.
It's just
Okay,
direction.
so the question was, so we have, let's say negative pi over 3 plus, I said plus 2 pi n. And you're saying, shouldn't that be negative pi over 2 plus negative 2 pi n, right? All right,
No, just get rid of the positive and subtract negative.
minus 2 pi n, is that, would you rather that? Is that what you're saying?
Right, and then n is always a positive.
Well, let's look at what these are, right? N, n is a member of the integers. That is, n can be any minus value and any positive value. So if I put in positive values here, I'm adding 2 pi times n, a positive value, right? That'll make this positive. But as soon as I put in a negative here, right, I'm getting kind of what you're looking for here. I mean, so I have negative pi over 2. Is that right?
Mm-hmm.
Is that the answer? No, negative pi over 3. Sorry. 3. Okay, so let's say I use this formula, right? So when I plug in 1, then it's going to be negative pi over 3 minus 2 pi. But when I plug in minus 1, it's going to be over here. It's going to be negative pi over 3 plus 2 pi. What I'm trying to say is it doesn't matter which way you describe it, because the n's are all these integers, right? All the positives and the negatives. Now, if it helps you to think of it this way, that's okay. There's nothing wrong with that. I just want to make it clear, you know, both of these are, you know, I would look at this and I wouldn't go, oh, that's not what I wanted. That's correct. So, everybody okay with this? Okay. All right. Making a mess of things here. The second one. Cosine inverse of minus 1. Thank you. Equals what? So, we take a look here. So where is the cosine negative? Well, the cosine is the x-coordinate, so it's going to be negative in quadrant 2 and 3. However, where is it minus 1? It's only minus 1 in one place. That's over here. So, what is this angle here? We'll use degrees now, 180 degrees, right? But that's, again, that's the principal value. That's the value if you use your calculator you can come up with. But we want all the values, so since the since the period is 2 pi or 360, it's plus 360. And again, to reinforce what we just said, it could be minus 360, right? Minus 720 and so forth. And we'll get all the values that way. Okay, now we come to the first place where you had to think on your own. You want to know where the tangent
Professor?
becomes 1. All right? For the tangent to be 1, the sine over the cosine has to be 1, which means the sine and the cosine are equal. So where does that occur? Well, it occurs at 45 degrees. Again, this is our isosceles right triangle. So 45 degrees is one place. However, at this point, you should start to think in terms of all the values. The sine and the cosine are negative in the third quadrant, so the tangent will be positive in the third quadrant. So what's that angle? That's 45 degrees plus 180, right? Which is
225.
225. All right.
Professor? Why the line didn't go straight? So the angle is gonna be from the 180 side, not the 270. Why did you flip it on, like you just inverse it?
I've gotten half of what you're asking. I'm still not. Why is this line straight? Is that
Yeah, why it didn't go from the other side?
I think what he needs is the point
Would
in
you
the
like to come
second
up and
quadrant.
show me what you mean? Because I'm not quite sure.
Sorry.
Want to use this or use this? No, don't use that on board because we won't be able to see it. There we go.
So
Just Foothill.
let's see, 45.
Okay.
And there's another one before you show us. It was 60, I believe. So the line was coming straight from here.
Because that was
60 and 120.
the
No.
sine.
Oh, okay. So
This is the tangent.
you're doing like this.
Okay. So what am I doing here? Yeah. That's, okay. I like what you did. Let's do that up here.
Yeah, just justify it.
So we have the tangent function. This is the other way to look at it. So I found half, which is over here, let's say. And if I draw a line over here, I guess what I'm saying is I'm going to hit this. Now I'm going to hit this point, but let me just kind of draw this. This is like the first quadrant, and then this would be, let's see, this would be the third quadrant. And this would be the fourth. And this would be the second. Except they repeat, right? They did that right. If this helps you find, this actually doesn't do anything. This diagram does something for me. It's like, I know that in this case, I didn't draw it perfectly here. But remember, this goes right through the center here, and it goes through the center here. So this is 45, this is 45. We need these. Basically, anything in the first quadrant you're going to find for the tangent, you're going to find the same value in the third quadrant. I mean, these angles are the same by vertical angles. Remember vertical angles?
Yeah, that makes sense.
So these ratios are going to be the same. The sine over the cosine is always going to be the same. All right, but we're not quite done yet, right? We have two values. We have 45 degrees and 220. I'm gonna write that as 45 plus 180 because that'll come in handy. All right, now here we have a difference to the first two problems because the period
Is pi.
is not 2 pi anymore. It's not 360. It's 180.
Amazing.
Everyone catch that? So what we really have is 45 degrees plus 180n and 225 degrees plus 180n. But if you think about it,
Do we actually need 225 if 180 plus 45 will do 225?
there must be a technical term for stating exactly what the professor was going to say next, exactly before he was going to say it. Since 225 is 45 plus 180, we don't need this, right?
Yes.
I mean, thank you. You beat me by a nanosecond.
You're welcome.
No, you're absolutely right. Okay, so that was the first three problems. What about the fourth one? There's actually some numbers involved here. So we want to find angles whose sine is 0.7777. Well, no doubt about it, we're going to need a calculator. And we're going to need our inverse function. Oops, we need our power too. Inverse function, 0.777. I believe we're still in degree mode, which is fine. All right, so I get a principal value of 50 point, no, actually, let's just call that 51.0. And by now you should realize we want the supplement of that angle, 180 minus 51. So that's going to be 129. And again, as before, 51 plus 360n and 129 plus 360n. And that gives us all the possible angles in degrees whose sine is 0.777. All right, why don't we stop there for now? Why don't we take a break? And if you have any business, you can transact it now. The tangent is 1, but then the tangent is going to be
You came from Russia today?
Huh?
You came from Russia? Cold, curve.
It's fucking cold there.
Yeah.
Really?
What time will you wake up?
I came here at 7:30.
7:30?
Yeah.
And you wasn't cold?
I just got this jacket.
No, like what's the earliest? Like when you wake up and go outside?
Oh, okay.
He came
7.
7.
I left home 7.
Oh, I thought you were talking about. Yeah, I mean, isn't it cold?
No, not what. Inside the car is not that cold. Unless you have a motorcycle.
Yeah.
So we just have to add 180. So We just have to add 360, because it's periodic, period 360, we just have to add 360 to get all of that. I have you absent. You must have come a little bit late. I got it.
Which value is it going
I want to see which homework. Okay, so now I'm happy to go over with you, but you did hear the part where I said I made a mistake and I should have made it due today. It's going to be due Monday. So maybe this problem. Number 8? 8, yeah. We're going to go over this. Oh, 13.
I'm familiar with that.
Okay. So let's write this down. So it says the sine of theta equals negative 0.4. Now let's also look at find all solutions over the interval 0 to 2pi. Okay. So what we want is we want inverse sine negative 0.430.
And then the angle that goes
So now we have to take a look on our chart. So
actually,
it's not the problem. Sine inverse.
This
Oh, the domain is -1. So that should work. Okay. And you don't think it'll work?
and so from here to
Oh, wait a minute.
to the,
I have an idea. Go ahead, type it in.
oh, no, I'm sorry, it's for Friday, Monday, Wednesday, Friday.
The minus.
but for cosine it's
It's like that.
Inverse sine. Yeah, okay, I understand. It's not gonna- That's it. Minus, this is subtract. So this is a syntax error. Okay, all right.
So you're still working on the summary or start this, the second one?
Okay.
So.
Let me draw a picture, I think, Nate.
Why is that?
Like,
Extra credit?
yeah, kind of like, right now is like, I can revise mine.
Actually,
And then like, if I do it again.
I don't know why it's so hard. They need some fluid.
Can you do
They need some.
Can you tell us
Let's do it here.
extra credit?
I want to draw you a picture.
And then either time is like, the first time.
Everybody else can look on the
We
overhead.
don't give any extra
So-
credit, so I didn't revise anything, but like, when I see.
Let's say I have some angle here.
He or she got her extra credit.
We'll just call it theta.
When we hand out our
So-
first essay, first summary, then we'll add some comments
No,
on
no,
some,
it's just
right?
any old angle.
Then
Any old angle.
adjust back.
And I'm gonna be looking at the
X
tangent of
X
that,
everyone
right?
in the past to revise it.
So,
But we didn't mention anything.
let's say this is A.
You can do it, and then you can get this.
So this is
Just
the,
like, I mean,
this
I
length is A, this length is B, and this is the
Yeah.
sine. It's okay. This is the sine and this is the cosine. So the tangent of theta is A over B.
I'm just too tired today.
Okay, now, I want you to remember a little geometry.
You follow the screen too.
Actually, it's not mine, it's somebody.
So I'm gonna-
that lives in the former.
continue that line.
They
We know this angle is the same.
It's useful.
And we know this is 1 and this is 1. And this is a right angle, like this. So we have a hypotenuse sledge. They're growing triangles. So the length of this is A, the length of this is B. So my point is that the tangent of this angle is also going to be actually minus A minus B. So whenever I have an angle here, if I look at its tangent, there's an angle over here, it's actually theta plus 180.
It's not like hard yet, so like.
Which has the same tangent.
Yeah, I mean, like, I know why you add like one stuff.
All right, thank you.
Why did you choose that quadrant?
Yeah.
You can also draw the
Because-
line there, and like make
Yeah.
the same.
Okay, so the tangent we're looking for is, well, the tangent is positive,
Yeah.
right? Right?
Is it
So-
something to do like this one?
So,
Yeah.
so the tangent is positive in this quadrant, and because both the sine and cosine are minus, it's positive in this quadrant.
Because like,
Yes,
yeah.
yes.
Yeah, that's just.
Where did this come?
I copied it from the text.
Very good, okay. But likewise, the tangent will be minus here and minus here. Does that explain it?
So, there's only 75 piece? Like,
You changed your hair.
It's not,
Okay.
it's
Is this
not
because I have
as
part of
dangerous
it
as
up,
people
so
think
it's,
it is.
okay, so you're not.
It's just exploding battery.
You
Let's
probably
get
haven't fully
everybody back
changed
in.
it yet.
If anybody's outside.
It's not even exploding, it just
Yeah, the battery.
burns out or whatever.
But it's their mistake. They make a bolt-in. If
Well,
they had it like the old version, you can just
Well,
change it.
first they
Not-
thought it's a battery, but then they realized that it's not a battery, it's actually the phone design. What? Like the reason why it's outside. Yeah, what the reason? Well, first they
Okay.
This part, second part.
yeah, it's the phone design overall, like some parts are overheating or maybe it's the controller ranges.
I think it's fast charging.
Yeah, maybe it's the controller which is dealing with the charging. No one's sure at this point.
Okay, so we've been dealing with inverse sines, cosines, and tangents, all of which you can find a button for on your calculator.
But not for,
Yeah, not for inverse cotangents. or inverse secant, or inverse cosecant. Now, I'm going to show you how we do these. This is the one thing I think today is a little tricky. Tricky usually means something is so simple that you go, what? So I just want to show you there's nothing up my sleeves here. This is going to be very simple, right?
Oh, I saw something. I saw something.
You saw something up my sleeve? Okay, let's watch carefully. I'm just going to write down CTN inverse of x equals y. Because if x were negative 3.8, I want to find out what y is. I'm going to find the cotangent of both sides of this equation. Now, we didn't discuss this, but when you have an inverse function, something you should know from Math48 1 or 2, when you have an inverse function, and you make that what you put into your function, or vice versa, get out x. Right? That's what an inverse function does. It undoes what the function does. And the inverse, I guess I should also say this. The inverse function of the inverse function is, of course, just the function back, right? So it doesn't matter where the minus is, minus 1 is. Okay, so I'm going to find the cotangent of both sides. So on this side, I just end up with x. On this side, I end up with cotangent of y. Now, I have a problem dealing with cotangents, so I'm going to rewrite this as the tangent, right? This is just 1 over the tangent of y. Or, with a little manipulation, you can see that the tangent of y is equal to 1 over x. I'm trying to do this really slowly so that I don't, it's so simple, right? Okay. Now, I'm going to find the inverse tangent of both sides. So, tangent inverse of 1 over x equals, what do I get when I do the inverse tangent of the tangent of y? Y. But y is what I'm trying to find, right? Now I know how to find y. I want to find the inverse cotangent of x.
Oh, so you put the
If I find, yeah. Okay.
1 over.
Oh, I love the moment of,
Light bulb.
yes, the light bulb moment. All right, somebody had a light bulb moment. I hope a lot of you had. To find the inverse cotangent of x, I just find the inverse tangent of 1 over x. That is to say, to solve this, I want to find, you go back up here, this is the tangent inverse of 1 over. Okay, let's try that. So, tangent inverse, in here a little bit. Oh, wow. Zooming.
Oh.
Machine. 1 divided by, and we had a kind of the opposite of the light bulb. The light bulb turned off and then it turned on. Remember, minus is down here, not here. Okay, minus principal value of cotangent minus 1 of negative 3.8 is negative 14.7, what does it say, 14.7. All right.
But that's not our problem.
That's not the problem.
Minus 37.6.
That's my problem.
Okay.
You have your problem. I'm doing my problem. All right. So let's take a look at my little diagram here. Okay, so the cotangent, like the tangent, is negative in second and fourth, right? So whatever this, wait a minute, is this degrees?
Uh-huh.
See, that's what's confusing, because when you do the problem number 6, it's literally like negative 1.52, and that's like,
Okay, all right, there's something funny going on. So,
would you have to put it in like,
oh, okay, I'm sorry, negative 14.7,
It's the fourth one.
that's
Yeah.
down here.
Yes.
It's close to 0, right? Let me draw a better diagram for this problem.
could you move it a little bit?
Yes. So really, this is the angle whose the principal angle whose cotangent is negative 3.8. I mean, it might help to look at 1 divided by minus 3.8. That's negative 0.2631, right? So we're looking for something that has a tangent that's really small. So it's going to be this very thin angle here. But that's the fourth quadrant. But in the second quadrant, we're going to have another angle. Again, it's going to be this plus 180. What was the answer? Negative 14.7 plus 180. Just like in that other problem with the tangent, I'm going to want to add the period times n, the period of the cotangent. But that's 180. So I can just say 180 n.
Oh, excuse me?
But he's doing a different problem.
Oh,
He's doing
doing different work?
Yeah.
I'm not doing your problem.
Yeah.
You're going to get to do your problem now.
Oh, okay.
If you jumped ahead and got confused,
Yeah.
oh, by the way, somebody left their work up here in case they, no, I think they disappeared. All right. Okay. We're not done. Let's take a look at the same question. What if I wanted to find the inverse secant of, I don't know, 0.32, let's say. So again, I'm going to go through that whole, process again. Secant of inverse of x is y. I find the secant of both sides, and I get x equals secant of y. I rewrite secant of y as what it is, 1 over cosine of y, or 1 over x equals cosine of y. And now I find the inverse cosine of both sides. And I find that inverse cosine of 1 over x is y. And now I can just plug in my calculator. Inverse cosine 1 divided by 0.32. And I get 47.2 degrees. And then I just have to do what I would always do with the cosine. I'd say, well, where is the cosine positive? All right, I've got one angle here, it's kind of close to 45 degrees. Right? So the cosine, of course, is positive in quadrant 1. Where else is it positive? Remember, it's the x coordinate. Anyone? Quadrant 4. So I could write the other angle, I could just write it immediately as minus 47.2 degrees. And then I'm going to have to add 360n to each of these. Okay? So you are now equipped to go on and do all the problems through 7. So, you already done those? Want to check them?
Will you?
Hmm?
How can I check them?
Oh, that's a good question. Hey, so remember when you were doing like algebra and you'd find a solution and the teacher would say, hey, here's an easy way to check the answer. Plug
Just
it
put in the
back
calculator?
in. So if you have a value for inverse cotangent, you have an angle, just find the cotangent of it and see if it's negative 37.6. All right, take a few minutes to do that. Like I said, this is the trickiest part, but it's not the hardest part. The hardest part comes later. Sure. Okay, so let's just look at 1 divided by 0.32. So that's not in the domain of the inverse cosine. I don't know which problem you're doing, but oh, ha! Got an error too. Do you see what my error is? 0.32 isn't in the domain. Nobody else noticed this. Like when I plugged this into the calculator, it didn't work because 0.32 is not in the domain of the inverse secant, right? I'd have to, here, change it. There, now try it. Okay. Okay. It's good to know what happens when things don't work. Then you won't be thrown when they happen to you. Yeah. The cotangent is negative, not the angle. Remember, we're finding like an infinite number of angles. Some of them are positive, some of them are negative. They all have a cotangent of negative, right? You see? Yeah. It's good to be able to keep that straight, right? I mean, yeah, I don't want to say anything about that right now. Too much. Okay. Right, so these should be pretty simple at this point, right? If I want to find the inverse cotangent of this value, what am I going to use on my calculator?
Tangent inverse. Inverse
Tangent inverse of what?
1 over negative
1 over negative 37.6. All right. And just waving my hands, we're going to find a value in the second and the fourth quadrant. And then what do we add to each of those to get the rest of the values? Pi. Okay. For the secant inverse, we're going to find what?
For secant,
Cosine inverse of 1 over 2.5. Okay. Cosine is positive in the first quadrant and the fourth. We get those values and add 2 pi. All right. Okay, everybody with me? Is now,
Can we
yes.
go through 6 just to confirm the answer?
Sure, that's fine. All right, so let me get the principal value here. So I say inverse tangent 1 divided by minus 37.6. So I get negative 1.523, 524, rounded. Okay, so again, that's a value up here. And that's where the tangent is negative, right? Wait a minute. Hold on. Let me start over on that one. Negative 1, this is an angle, 5 to 4. Right? Again, this is a very tiny angle down here. Right? That's my negative 1.524 degrees. Right? I'm not in radians, am I? Okay, so the angle, that's the angle in the fourth quadrant. The angle in the second quadrant is going to be this plus 180. So we really can just say negative 1.524 plus 180n, because that's going to take us not just to this one, but then around wait, I'm sorry. That was number 6? Yeah, number 6. Cotangent, the period is 180 or pi. So I have to add 180n to that value. Is that okay?
Yeah.
All right.
So it's going to be 197, 179. The first one 1.52, and the second one 179.
A little less than 179, yeah. I don't even need to write it down. This is my answer. That includes all the possible values.
Can we also do the remaining 2? 7 and 8.
We're not ready for 8 yet, right? Sure, let's do this. Okay, so we decided that was cosine inverse of 1 over 2.5. So that's cosine inverse of 1 divided by 2.5. So So that's 66, I get 66.4 degrees approximately. Okay, so now that's a cosine value up here. The other cosine value we're going to get by drawing a horizontal line here, and that's this angle down here, which is negative 66.4. So the solution is 66.4 plus 360 n, right, 2 pi, and negative 66.4 plus 360 n. And that's the whole list of possible solutions.
So what we decided, how did you get to the negative 66?
This angle here and this angle here are the same, except the negative of them. I mean, you could add, okay, so you could take the supplement plus 180, and then you get negative 66.4 plus 360. That's the other way to do it. Okay, are we good? All right. Now we have to do a hard problem. Okay. So now we have an equation here. Sine of 3 theta equals 0.469. And we want all the solutions between 0 degrees. Oh, sorry. Ooh. I'm sorry. Sine of 3 theta equals 0.469. We want all the solutions between 0 and 360 degrees. Okay, so the first thing we're going to do is pretty straightforward. We're going to say, what's the inverse sine of 0.469? So that's just a calculator question. Inverse sine of 0.469. And we're going to just say 27. Just going to carry an extra digit here. All right. But that's 3 theta, right? So we're just going to divide this by 3. And we're going to get 9.323. Okay? Remember, we want all the solutions. So let's go back and look at this for a second. Here we have 27.97, that's our sine value. But we can also get that in which quadrant? That's the first quadrant. Where else is the sign going to be positive?
Second.
The second quadrant. So inverse sine of 0.469 is also equal to 27.97 plus, I'm sorry, not plus, 180 minus 27.97. All right, let's find out what that is. 180 minus 27.97. Okay, that's 152.03. But again, that's 3 theta, so we want to divide that by 3. And that's another value, 50.67. Okay. So this is working okay. We're finding where the sine of something is 0.469, and then we divide it by 3. what are the other possible values, angles, whose sine is 0.469? Well, we've been doing this all along. We've been saying, okay, it's 27.97 plus 360 and 152.03 plus 360n, right? Well, some of these, I mean, there's an infinite number of values. Some of them divided by 3 are not between 0 and 360. Move up. Yeah. Some of them are not what we're looking for. So let's just take a look at one more here. Let's look at 27.97 plus 360 and divide that by 3. That might be one of our solutions. Right? So 27.97 plus 360 and divide that by 3. Oh, okay. 129.32. That's another solution. I guess I should circle these. All right, now let's look at 152.03. Right? 152.03 plus 360 divided by 3. And we'll divide that by 3, and that's 170.68. It's another value. I don't think we're quite done yet. Because I could add 27.97, do that down here. 27.97 plus 360 times 2, that's 720. Divide that by 3. Let's try that. 27.97 plus 720 divided by 3. That's 249. Another possible value. And finally, let's try 152.03 plus 360. I'm sorry, plus 720 over 3. 2.03 plus 720 divided by 3. 290.68. All right, let's keep going. All right, just see where we run out of steam here. 27.97 plus 360 times 3 over 3. So 27.97 plus 360 times 3. Does everyone see what I'm doing here?
Yeah.
Is there a no? All right, now look at this value. 369. That's past what I'm looking for. Remember, I just want solutions between 0 and 360. So while this fulfills the requirements, it's not one of the numbers I'm looking at. So what have I found here? My thetas, my solutions are 9.323, 50.67, 129.32, 170.68, 249.3, and 290.68. So I have 6 solutions to this original equation. Now, if you're feeling lonely and bored tonight, you can plug them all back in and check. But I'm pretty sure that's correct. All right, so this is a little tricky now. This is much harder than what we've done before. But again, the basic strategy is find out what all the values are of sine of x equals 0.469. And then find out which of them are, divided by 3 or between 0 and 360. Now, you may try problem number 8. See if you can find any pattern here in the solutions. Right. Correct. It does not get you all the solutions. Here's the list. Oh, I'm sorry. I don't think that's the solutions. I'm not sure. I thought you were talking about this problem. No, this one. So what did you do? You said well, this is 2 of the solutions, but you see you're not looking at the other one. Okay, so think about this. 2 theta is 25.8. Right? So that's the cosine of 24.8. Gives you the right value. But there's another angle in that unit circle that will also give you the same. The cosine of it will also give you the in other words, your angle is here. This angle, negative 12, also cosine of it will also give you. So you have to now divide it by 2. That's not what you want. But add 360 to this and divide by 2. And it will. Notice you have to find all the angles, right? 12.9 plus 360. Negative 12.9 plus 360. Right? So 12.9 is one of them. You divide that by 2. I'm sorry. I'm working on a false assumption here. Inverse cosine of 0.9 is 25. I'm sorry. It should be 25. So 25 divided by 2 is one answer. 25 plus 360 divided by 2 is one answer. Negative 25 plus 360 divided by 2. You see that? Let's just try that approximately here. 360 minus 25 divided by 2. Okay, so now when we take back, we multiply by 2. And then we find cosine. See where that came from? Okay.
Could you put your solutions up for the one that you
For number 2, I mean for number 8.
Yes, for the one that you, the example. The example.
I'll do the problem, but I want to give everybody a chance. Has everyone had a chance to do number 8?
Yes.
Is anyone still working on 8?
She's cheating.
Are you still working on 8?
No, I'm done.
Okay. All right. So, someone want to throw out an answer to number 8? Just give us the solutions. We're going to go in reverse order, right? Everybody's done it, right? Somebody has to have an answer. Nobody has an answer? You wanna?
Yeah, I have, for theta or for two theta?
For theta,
I have a 12.921
okay?
and 154.2.
I'm sorry, 154,
Yes,
4.2.
yes, and I was just getting the other ones.
Oh, there's another one. Okay. Does anyone have the other one? Yes,
There's another two.
there's another two. All right, come on, let's have it.
77.079. Oh, wait, I have completely different numbers though.
I got that one.
Okay, so I got 12.921, 77.079, 192.921, and 257.07. I think that's a 9.
Okay. We're approximating here. All right. 1, 2, 3, 4, 5 maybe. All right. Now, I don't usually do this, but let's just give it a shot here. Let's say cosine 12.921 times 2. Yeah, that's pretty close, right? Cosine of 154.2 times 2. I'm doing this because, put a little circle around that. That didn't seem to work right.
Mistake.
All right. I think it's a good idea to get into the habit, especially when you're doing an exam. Ah, interesting. Negative 0.999. All right, that didn't work, did it? All right, let's keep going here.
Try 102.921.
102
921.
times 2. And another negative.
Then
That's not what we want.
Then try 167.1. 167.1.
Ah, that looks good. Oh, that looks like a good one.
Nice.
167.1. Let's try these other ones just to see what happens. Cosine 192.921 times
Then
2.
this one will be
Yeah, that's a good one.
Yes.
Good one. That's a good one. Let's just try this last one. Cosine 257.079
Will not
times 2.
work.
Now that's negative again.
Yes.
All right. So
It will be
we have 3 solutions.
347.
Maybe they're all the solutions, maybe they're more. Let's go through it a little more methodically.
The last one will be 347.1.
I'm sorry, what?
347.1.
All right, let's try it. Cosine 347.1 times 2. Yeah. I missed that one. The first round. All right, let's take a look here. We know that cosine of 2 theta equals 0.9. So let's find out what values 2 theta can equal, right? So we start off with inverse cosine of 0.9, and we get 2 theta can equal 25.884. That's good enough, right? But if the cosine can be 20, if the cosine of 25.84 is 0.9, what other value is there in the 4th quadrant?
Minus 25.
Yeah, minus 25.84.
It should not.
So what we want to look at is 2 theta equals 25.84 plus
2 pi.
360 n, and 2 theta equals negative 25.84 plus 360 n. So, when n is 0, these two equations give us one solution, right? This one gives you a negative 12 point something, but that's negative. That's not between 0 and 360, right? So this just gives us one number. I'm going to write them down here, 12.92. Okay, that's number 1. Adding a negative 1 to either of these is going to give us a negative number, so there's no point in doing that, is there? All right, but we can add 360 to each of these. So let me do that. Let's say 25.84 plus 360 and divided by 2, that gives me 192.92. And let me add minus 25.84 plus 360. Divide that by 2. That gives me 167.1. And now I want to try adding 720 to each of them. Well, actually, I know that's not going to work for the first equation. Because when I divide 720 by 2, I'm going to get 360. And when I add that to 25, I've got a number greater than 360. So the only one left here is if I add 720 to this number. This is the one Jessica, this is the one I missed when we were talking. You can add 720 to negative 25.84 divided by 2, and you get 347.1. So here we have 4 solutions. All right, I think now the assignment on the website is in force. I would spend more time reviewing for the for the quiz, but do try and get that done, say by Wednesday, and bring in questions. You can bring in questions on Monday, and we can go over that after the quiz. We're ending up a little early today, so what I'm going to do before you stand up is I'm going to make a proposal. So my proposal is, if you just want to go home early, you'll be able to do that. But if you want to stay for maybe another 10 minutes, I'm going to discuss an interesting topic that will not go over your head.
How interesting is it?
Very interesting.
Is it like
It's
quantum mechanics?
It's not quantum mechanics,
mathematically
except
or
quantum mechanics is physics. This is math.
Yeah, I know.
It won't take long. So those of you who wish to go, no points against you.
like real life application?
Nothing I say after you leave will be on any quiz or test
mobile
ever
development.
got here.
Cloud support.
But clear out, so we can get going. All right. Yes. Yes, that's exactly right. Because 2 theta is equal to, here. 2 theta is equal to 25.84. So theta is 25.84 divided by... Oh, if you like, yes, that's right. That's right.
Did you get it?
What you want? What you want? What you want? What you want? What you looking at? Are you interested in me? Far from it.
What are you doing here? Go home.
All right, oh, so